Okay, for geometry, we are on lesson 9.5, and I taught tangent separately, but I'm going to teach sine and cosine together, and I'm going to explain why, but you're going to understand why here in just a second. So sine and cosine ratios are the last two of our trig ratios. There's three trig ratios. One was tangent, and then sine and cosine. So the sine and cosine ratio is the ratio of a leg and a hypotenuse. So we're going to look at the leg and the hypotenuse of a right triangle. Remember, trig always happens, or at least for now, with right triangles. So the reason that sine, the E dropped off of it, is because I think honestly it's because it's in your calculator. They can only fit like 3 letters. Well, no, this one fit like 7 letters, so I don't know why. But in calculators, they usually just use 3 letters. So it looks like sin and tan and cos, but this is actually pronounced sine, cosine, and tangent. So I will keep saying sine, even though it's usually written like that. So the sine ratio of, let's say, angle A. So we're looking from angle A. So from angle A, the sine ratio is the opposite leg over the hypotenuse. Remember, these are always legs and hypotenuses. So opposite leg over hypotenuse. So we're going to write opposite leg over hypotenuse. Okay, and then that can also be written like with the actual side lengths, which would be sine A is equal to, what is the opposite leg? Looks like it would be BC over AB. So BC over AB. Okay, for cosine, the cosine of anything, or specifically in this case of A, is going to be the adjacent leg. So let's make sure we know which one's adjacent. The adjacent leg over the hypotenuse also. So hypotenuse is what we're dividing by in sine and cosine both. So from A, we're talking about the adjacent leg. So not the hypotenuse, but remember, adjacent means right next to it. So if we're talking about right next to this angle, we're talking about part of what makes it up. Not the hypotenuse, but the adjacent leg. So it's just this leg. If we were talking about this leg, it would be the opposite. But we're talking about the one that's adjacent to it, so it's going to be the other leg. So the leg adjacent and the hypotenuse. So let's write what those letters would be. So for cosine of angle A, that would be side lengths or sides AC to AB. So AC over AB. All right, just practicing writing those ratios. Let's find both the sine and cosine ratios of the whole right triangle. So that means we need to do both acute angles. So let's start with sine R. So for sine R, remember sine is opposite over hypotenuse, and if we're looking from R, opposite would be 16 over hypotenuse is 65. I don't think that simplifies. If it did, we would, but I don't think it does. Then let's do sine of the other acute angle, which is S. So from this acute angle, opposite is 63 over hypotenuse is 65. So that would be 63 over 65. Okay, it also wants us to find cosine ratios. So I'm gonna, don't mind my dog, there's someone walking by our house and he thinks that he needs to bark at them. All right, so for cosine R, remember cosine is adjacent over hypotenuse. So if we're going from R, adjacent would be this 63. Remember, it's not the hypotenuse or the opposite, so it's the other one, it's the adjacent. So 63 over hypotenuse, which is 65. And then cosine of the other one, which is S. If we're looking from angle S, the adjacent leg would be this one. It's not the opposite, it's not the hypotenuse, so it's the adjacent leg. So that'd be 16 over hypotenuse. So 16 over 65. I don't think that simplifies. You guys are going to have to tell me later if it does. I'm not going to take time to do it. Okay, here's what I want you to notice. Just looking at these ratios, can you see that sine R is 16 over 65, and so is cosine of the other angle S? And then in that same way, sine of S angle is 63 over 65, while the cosine of the other acute angle R is the same thing. So there is a relationship, which is the reason I'm teaching you sine and cosine in the same lesson. And the relationship is that the sine of an acute angle, of either acute angle, but we'll just say one for now, the sine of an acute angle is equal to the cosine of its, let's use a fancy word, of its complement. So think about what that means for a minute. We already talked about complementary angles. Those are the ones that add up to 90, and the acute angles are the two that add up to 90, because the other one is 90. So the sine of one of the acute angles is equal to the cosine of its complement, which basically is a fancy way of saying of the other acute angle. So here are the, you could have come up with this on your own at this point, I guess, rules. So if sine A is equal to the cosine of the 90 degree minus whatever angle A was, that gives you the cosine of B. So sine of B would be cosine of whatever 90 is minus the angle B, and that equals the cosine of angle A. This seems very confusing, but if you're following me, I think you're like, okay, I get it. This is just a lot of writing. So, but cosine of angle A is equal to the sine of 90 degrees minus that angle A, which would equal whatever the sine of angle B is. And then last one, cosine of angle B is equal to the sine of whatever 90 minus angle B is, and that is equal to the sine of angle A. Okay, I mean, I think as long as you know what I mean by that, writing it all out doesn't really matter. Okay, let's actually do some work now. So using this, what we just came up with, those wordy things, write sine of 56 degrees in terms of cosine. So the sine of the 56 degree angle is equal to the cosine of 90 minus that 56 degree angle, which means it's equal to cosine of, I don't know if you did that math in your head, I think it's 34. Okay, I think that's going to help us. So let's use sine and cosine to calculate x and y. This is actually why we use trig, because sometimes you can't use Pythagorean theorem. So look at this. We know that one angle is 90, and we know the hypotenuse is 14, and we know 1 degree is 26, but we're not going to be able to come up with either of the other two sides based on only knowing one side, unless you have trigonometry. So I would first, let's do x first. So I'm going to do step one. We're going to find x. For x, oh, you know what? Even if we go from this angle, it's still going to be over the hypotenuse. Sine and cosine are both over hypotenuse, so we're going to have hypotenuse on the bottom either way. That's for our next one. We'll worry about that. So let's do sine of this angle, 26 degrees. And it equals, remember, sine is opposite over hypotenuse, so x over 14. This one actually is okay. I was thinking in my head about a different one. So what you would do to solve for x is being divided by 14, so you're going to multiply by 14 on both sides. You did this a lot with the previous lesson with tangents, so I'm sure you already know how to do this. It's not going to come out pretty, so I'll put about, x is about, I don't know, sine of 26 times 14. Should be about we'll say 6.1. So let's just call this, it didn't say what to round to, we're going to round to the tenths. So x would be about 6.1. Okay, let's do y now. So for y, we could subtract from 180 and get this one up here. It's not really going to matter. Let's just use cosine for this one. So we'll do cosine of 26 degree angle. We'll keep it with our 26 degree angle because cosine is adjacent still over hypotenuse. So we're still just y over 14. So really this doesn't matter. All right, to solve for y, it's being divided by 14. Simple algebra, you're going to multiply by 14 on both sides to get that to cancel. And y, this is not going to come out pretty either, but that's okay, we'll round to the tenths again. So cosine of my 26 degree angle times 14. That is, we're going to call it 12.6, about 12.6. I would always make sure that that makes sense. Like, you know that the hypotenuse is always the longest side, so 14 is the longest, should be the biggest number. So those look reasonable, like reasonable answers. Okay, I know we've talked a lot about 45, 45, 90 triangles and 30, 60, 90 triangles. Those are our special types of triangles. You should know that obviously they're 45, 45, 90. Sine of 45, I'm just going to have you have this in your notes because sometimes it will come up, but you would be able to solve it later. But just kind of as a general rule of thumb, sine of 45 is opposite over hypotenuse, so 1 over root 2. And what you might remember is you can't have a radical in the denominator, so we have to rationalize that by multiplying by 1. But the 1 looks like root 2 over root 2, and that would be root 2 over root 4, which simplifies to just 2. So this is your answer. Sorry about my dog again. And we'll go ahead and get the decimal answer of it. It's going to be about root 2 divided by 2. I don't even know. Root 2 divided by 2. We're going to go 4 decimal places out. So we'll go 0.7071. 7071. Okay, for cosine 45, it's going to also be 1 over root 2. So that's going to, I'm not going to do all the work because I already know the answer. It's 0.7071. And tangent was our previous lesson. Tangent is opposite over adjacent, which opposite over adjacent would just be 1 over 1, which is 1. Okay. For our 30, 60, 90 triangle, we're talking about the 30-degree angle, so we're always looking from this one. For our 30-degree angle, for the sine of the 30-degree angle, that would be opposite over hypotenuse, so 1 over 2, so 1/2. And since we did decimal answers, we'll keep it decimal, 0.5. For cosine of that 30-degree angle, cosine, remember, is adjacent over hypotenuse, so that'd be root 3 over 2. That's going to probably need to be rounded. So let's see what that is. So root 3 divided by 2 is, we'll go 4 decimal places out again. So we'll go 0.8660. 0.8660. And then for tangent, remember tangent is opposite over adjacent. Opposite over adjacent, so that's 1 over root 3. Can't have a radical in the denominator, so I'm going to rationalize it by multiplying by root 3 over root 3, which would equal root 3 over root 9, which the square root of 9 is 3. So let's find out what that decimal is. Root 3 divided by 3. Square root of 3 divided by 3 is, we'll go 4 decimal places out, 0.5774. 0.5774. Okay, this is just going to be handy to kind of have in your notes because in a typical 30, 60, 90, you might need these decimal numbers, and in a 45, 45, 90, you might also. Okay, you might remember a couple lessons ago, or maybe it was the last lesson, I can't remember, we had angle of elevation. So this time you're skiing, so you have an angle of depression. So there was elevation when it was raised, when it was from the horizontal line upward, your line of sight was going upward. And now when your line of sight from the horizontal line is going downward, it is called an angle of depression instead of elevation. So let's put the definition. The angle, a downward, I'm going to make this in caps because the one before was as your line of sight is looking upward. This is as it's looking downward. Line of, let me go to the next row. Sight, line of sight makes, the angle that it makes with a horizontal line. With a horizontal line. So make sure you know the difference between the angle of elevation and the angle of depression. You're either looking up from the horizontal line or looking downward from it. So that, we're trying to find how far you're skiing. So this is your little problem. X is your hypotenuse. The angle of depression is 21 degrees, and all we know is that opposite it, the height of where you're at to where you're going to go is 1,200 feet. So think for a minute which one you would use, if you would use sine or cosine, maybe tangent. We don't know the adjacent leg, and we don't know the hypotenuse. So either way, this is the one my eyes went down to earlier when I was saying we're going to have x on the bottom either way. So it's probably good. Let's review how to do that one. So let's choose, doesn't matter. We'll choose sine. We'll do sine of 21 degree angle. So let's say we're doing sine of the 21 degree angle. Sine 21 equals, and remember that sine is opposite over hypotenuse. So from this angle, the opposite is 1,200 over the hypotenuse is unfortunately x. So we've got 1,200 over x. When x is on the bottom, it just takes an extra step. It's kind of annoying, but it's not difficult. So 1,200 is being divided by x, so the first thing you're going to have to do is move x. If it's being divided, you're going to do the opposite, which is multiply by x. What you do to one side, you're going to also do to the other, so that they cancel off over here. So now we've got sine of 21 times x, instead of writing them up and down, I just wrote them left to right, is equal to 1,200, so now we can solve it. These two are being multiplied, so to get x by itself, we're going to divide by sine 21 on both sides. They cancel here, so x is going to be, we're going to say about, because anything with trig usually does not come out nice and neat. So 1,200 divided by the sine of 21 degrees. And nope, did not come out pretty. It is going to be about 3,348 point, we'll just say 0.5. So 3348.5. And that is how far down your angle of depression, not your angle of depression, sorry, your hypotenuse that you're skiing. Okay, I don't like the way some people do this story. It doesn't sit well with me, so I don't want you to look at that story, and I also don't want you to look at the word chief, but I am going to tell you something that I want you to put together now that you've learned tangent and sine and cosine. The word is SOHCAHTOA, and I'm sure your parents can remember SOHCAHTOA if you go tell them you're working on trig and you learned the little catchphrase SOHCAHTOA. I even made a little bit of a space here and a little bit of a space here on purpose. I kind of separated them. So SOHCAHTOA. SOHCAHTOA is all three of the trig ratios. So stands for sine is equal to opposite over hypotenuse. This is just going to help you memorize it. Ka means cosine is equal to adjacent over hypotenuse. And toa is the one we learned the last time, which was tangent is equal to opposite over adjacent. So anyone who has trouble memorizing, you can remember SOHCAHTOA, and that is how to remember the trig ratios.